Okay, exponential functions. Today we're going to talk about applying them to real life scenarios, population and finance mostly. You want to be a banker? That thing to know. You'll have to know it actually. Or scientists. Scientists use this stuff all the time. So, you remember the general form of an exponential from yesterday? We're just going to play on that. Okay, so these next two equations are based on this. And the first one deals with exponential growth or decay. So we're talking populations, carbon-14 dating, anything that falls into that realm of thinking. Here's the formula. So basically, you just plug things into it. It's the same as y equals a times b to the x. We just expand it to consider a field of science or population or something. It's just a different application. Okay. So this would be your strictly math theory. This would be your apply it to something. N is your final amount. N0 is the initial. So this basically anything you see in math or science with a subscript 0, that's your starting amount. I started with $2,000 in my bank account. Or in 1900, Los Angeles had 500,000 people. Okay, that's your starting amount. R is rate of growth or decay. Per time period. And T would be number of time periods. Okay. Be careful with R and T, because sometimes you're given R in months and T in years. They have to be the same, so you kind of have to translate that, okay? At its most basic, they will give you the same, but sometimes they kind of change it up, just like what happens in the real world, right? Okay. The example I have here is just a city, so it's kind of boring. So let's consider a city. Okay. With an average annual rate of population growth (7.5%). No, this is not Parachute. Maybe Denver at this time. The place has exploded. Let's say the population right now is 22,750. What's the population in 10 years? Chance. Think you can handle this one? What's 7.5%? Yeah. Remember to change it to a decimal. 0.075. This is N0, and this will be T. This one's pretty straightforward. Calculator. 46 what? Is that what you said? Yeah. Of course, it's an estimate. We can't
have a half person.
Anybody in here know the population in the future?
Doesn't it decrease?
If so, what's the next big stock? Spend all the money on it. So is that pretty straightforward? Okay. Here's another way we can ask a question. When will the population? What do you want to do? Double or triple? What's our unknown on this one? T, yeah. So we have to do a final amount of 3 times 22,750. The initial's still the same. The rate's the same. We just don't know T. Yeah, solve for T. Can anybody solve that? What's the inverse of an exponential? Remember, we're working inverses to undo, right? The teeth root. You guys don't know how to do that. It's called a logarithm. You don't know logs. That's part of the chapter too. I kind of threw this one at you just to see what you do. But you can kind of guess and check, right? What? Try 20. What's 1.075 to the 20th?
4.
Oh, so that's a little bit large, right? So maybe 15. That's pretty close, huh? What is 16?
3.1.
Okay, so we would say the population will triple between 15 and 16 years from now, right? So you're going to have to estimate at this point. So that's one solution technique. Now, when we get to logarithms, it's going to give you, you're going to have an exact answer. No. A couple weeks. Logarithms are really neat because they model pH and earthquakes and all sorts of cool stuff.
I digress. We move on. Okay, finance. Any of you have a bank account? Yeah, a few of you? Okay, here's an equation. There's an equation that you can calculate how much money you'll have in your account after so many years. This is without adding anything to it or taking anything away from it. So it's just a basic, if this is what I have, here's what I'll have in 10 years. We'll go over the other ones. Just today we're starting basics. So again, final amount, initial amount. That's called principal. So we're in a finance mindset now. So the formula is financially suited. Okay. So we call it principal. Our annual interest rate very rarely will they tell you monthly interest rates or anything of that nature. Be very wary if they do. N is a number of times interest is paid each year. Okay, and then T is the number of years. So if you have a bank account and they say you have an annual interest rate of 5% compounded monthly, N would be 12. So you gotta be careful there because they'll change the units on you. Like I said, you can't really add or subtract from your account for this to work. Have you guys ever heard of certificates of deposit? No? Anybody? No, not a bad idea, but okay, it's basically you go to the bank, you buy a certificate of deposit, so you give them $5,000, and they give you a certificate that you deposited $5,000. You can't take away from it or add to it, and they say we will give you 3% per year for 10 years. You can have your money back in 10 years. Okay. So you basically are investing in the bank. They use that money to make loans to people. Right? So let's say you bought a CD, certificate of deposit. Hey, when I was your age, I rolled by the bank and it said huge CD sale. And I was like, man, compact disc sale. I better go look at that. Yeah, it was totally wrong. Let's say $9,000 and 6% compounded quarterly, and let's say it's a 10-year CD. Okay. How much money is in it after 10 years? 6% is not a bad rate of return.
What's like the highest rate you can get?
Right now? Oh, they're not handing out more than 1 or 2%. It's barely even inflation. Like we have a savings account that is earning like 0.1%. Because the Federal Reserve Bank has pegged their base interest rate at 0. So everything's based on that. Like that's why house loans are so cheap right now. Our house loan was 3.25%. But let's say when I was born in the late 70s and 80s, the interest rate was the base, I don't know what they'd set it at, but they were giving house loans at 15% interest rate. You know, so instead of my $700 a month, I've been paying like $1,500 on the house. So, but at the same time, savings accounts were earning like 10% a year. But inflation was also 10% a year, right? So they kind of, to play with the numbers, and you guys will learn a lot more about it in economics. They try to play with that interest rate to, right now they're trying to kick the economy along. So who knows if it's going to work or not. That's where it all started, yeah. The economy was in the tank at that point. Nixon and Carter totally hosed our country. Nixon, not only because of his ethics.
He's not a
Touche. That's what he said. Okay, so what's our, here, let's finish here. The principal is 9,000. 1 plus, what's N? Quarterly, how many times a year is that? 4. 4 quarters. 1 quarter, 2 quarter, 3 quarter, 4 quarters. That makes a year. So, and then the time is 10. Calculate.
I got 18,000.
16. Two what? 1. We are in money and we do go to cents. Right? Okay, so that's a basic finance question. Uh-oh.
I rounded to the first.
What did you get? 10,000 I'm pretty sure is not going to be correct. You probably typed it in wrong somehow. We'll come look at it. That looks to me to be right. I don't have the answer here. So.
That's what I got too.
Okay. Right. So you have the homework from? Yeah. I need to write it down again. Okay. Enjoy.